Okay, page 4 of the addendum for differentiation rules. So first we're going to talk about the inverse trig function derivations in section 18I. Remember that arcsine is basically the inverse function of sine. So you give it the ratio and it gives you the angle, which is the exact opposite direction that sine does, right? So I could rewrite y equals arcsine of x in terms of x by putting x equals sine. Okay, now the next step is to use implicit differentiation with respect to y to find the derivative of dx dy. Now there's two things weird here. Instead of taking the derivative with respect to x like we normally do, we're going to take the derivative with respect to y. And so what we're going to end up with is an expression for dx dy instead of dy dx, okay? You could do it the other way too, but this is the way they do it in the book. So if I take the implicit derivative of both sides, I'm going to have, on the left side, I'm taking it with respect to y, so the derivative of x with respect to y is dx dy. And on the right side, the derivative of sine y with respect to y is going to be cosine y. Right? And we don't have to do the chain rule because we're doing it with respect to y. Okay, so we're going to put here that dx dy is equal to cosine y. Then we're going to use the Pythagorean identity to eliminate cosine from the expression and replace it with sine. Okay, remember, the Pythagorean identity is sine squared plus cosine squared equals 1. And I can solve for cosine by subtracting sine squared from both sides. And then we'll end up with cosine squared equals 1 minus sine squared. And then we'll take the square root of both sides, and we'll end up with that cosine is equal to the square root of 1 minus sine squared x, right? Okay, and then it says to eliminate cosine of y by substituting in this expression here. So instead of cosine of y, I'm going to have square root of 1 minus sine squared y, right? Okay. Oh, and the left side is dx dy, right? Then I'm going to replace sine y with x because remember, x equals sine y. Then I would have dx dy equals square root of 1 minus x squared. And finally, I want dy dx, not dx dy. So I simply invert square root of 1 minus x squared. So then I end up with 1 over square root of 1 minus x squared. I'm done. Okay? So that is the derivative of arcsine of x. And it's defined for this domain because what you're inputting is the ratio, the sine ratio, and you're getting the angle out. Okay. So here basically, if you do that same procedure to arc cosine and arctangent, you're going to get these two rules here. Now let's try to use these rules. So we're going to find the derivative of arctangent of 2x. So arctangent, the derivative is this here. So the derivative of arctangent of something is going to be 1 over 1 plus that something squared. And the something happens to be 2x. Now I'm going to take the chain rule of 2x, which would be 2. So that should be the derivative of arctangent of 2x. I can simplify it a little bit. I'll put 2 on top, and then on the bottom I'll have 1 plus 4x squared. Okay? Alright, let's look at C. Y equals the arcsine of x over 4. The derivative of arcsine of something would be 1 over square root of 1 minus something squared. The something in this case is x divided by 4. And the chain rule, the derivative of x to the 4, x over 4 would be 1/4. So let's try to simplify that a little bit. On the bottom, right? Now, if I multiply this 4 times the denominator, that would be the equivalent of multiplying by 16 inside the square root sign, right? Because it would be 1 over the square root of 16. I could put the square root of 16 inside the square root sign. So I would have 1 over the square root of 16 times 1 minus x squared divided by 16. And then if I distributed the square root of 16 there, I would get 1 over the square root of 16 minus x squared. Okay. Now let's do the derivative of arctangent of 2x squared. So the derivative of arctangent, remember, is 1 over 1 over 1 plus x 1 plus something squared. So I'm going to put 1 over 1 plus something squared. The something is x squared. And then the derivative, chain rule, of x squared would be 2x. Okay, let's see if I can simplify that. 2x over 1 plus x to the fourth. Now let's find the derivative of y equals x times arc sine of x. Now remember that this is taking the derivative of product, u and v. So first we're going to write u, which is x, and then we're going to multiply times the derivative of v, which is arc sine of x. Derivative of arc sine of x is 1 over square root of 1 minus x squared. Okay? And that would be u times v dash. Now we're going to do u dash, which is 1, times v, which is arc sine of x. So if I wanted to simplify that, I would do x over square root of 1 minus x squared plus arc sine of x. 3c, I have y equals e to the negative x arctangent of x. So for this one, I am going to do the derivative of product again. So first I'm going to put u, which is e to the negative x, and then I'm going to multiply it times v dash, which is derivative of arctangent of x, which would be 1 over x, 1 plus x squared. And then I'm going to add that to u dash, which is negative e to the negative x, times v, which is arctangent of x. Okay, the last section are some of the more difficult problems for a second and higher derivative section, J. We're going to do implicit derivatives here because we didn't do those in the SL book. So let's take two derivatives of, with respect to x, of this expression here. So let's see. First, we'll take the derivative of x squared. It'll be 2x, since it's with respect to x, no need for chain rule. Then we do the same thing with y squared. We get 2y, but then we do the chain rule on y, so it's dy dx. And then the derivative of 25 is just 0. So that would be the first derivative. And then to take the second derivative, we just repeat the process. And on the first term, 2x, the derivative would be 2. And then the second term, the derivative would be, let's see, it would be a product, right? It would be u and v. So first it would be 2y times the derivative of v, which would be the second derivative of y with respect to x. And then we would add that to u dash, which would be the derivative of y would be the first derivative of y, and then we would just write down the v itself, which would be also the first derivative of y. And the derivative of 0 would just be 0. So now what we get is 2 plus 2y dash plus dash dash plus 2y dash squared. What we want to do now is solve for y double dash. We have y dash in here. We don't want that anymore. Can we solve for y dash here and put that expression here and just have x's and y's in it? Let's do that. So like this expression here, if we solve for dy dx, we would have negative 2x divided by 2y. Let's go ahead and do that algebra. So we'll have we have 2x minus or plus 2y, y dash equals 0. So we'll subtract 2x to the other side, and then we'll divide by 2y, and we'll get y dash equals negative x divided by y. And we can put that expression into here. So then we have that squared, which is a little bit nicer than what we have here. So then we'll have 2 plus 2y, y double dash, plus 2 times negative x divided by y. So I'm going to put x divided by y, and then I'll change this to negative, equals 0. Squared, right, equals 0. And now I'm going to take these two pink ones and I'm going to subtract them over the right side because I want to solve for y double dash. So I'm going to put the pink ones on the right side first. And to do that, I have done this here. So I have 2y double dash equals negative 2 plus 2x y squared, x squared divided by y squared. Then I'm going to divide both sides by 2y to isolate the y double dash. The y double dash is the same thing as d squared y divided by dx squared. So I'm going to have negative 2 plus 2x squared divided by y squared divided by 2y, which is from this side. And then I can cancel out all the 2's, and the first term is going to be negative 1 over y, and the second term is going to be x squared divided by y cubed. And I'm done. Okay? Now let's move on to C. Similar expression here. So I'm going to take the derivative of the first term, the derivative of 3x, x cubed is going to be 3x squared, and there's no need to take the chain rule because I'm taking with respect to x. The next term is going to be a product, u and v, like that. So it's going to be 2 times x times the derivative of y, and then plus 2 times the derivative of x, which is just 1, times y. And the derivative of 4 is just 0. And now I want to solve for y dash, or I want to take one more derivative, right? So, let's see, it'll be 6x plus, and then now I'm going to do like a product rule here. So it'll be 2x times the second derivative of y plus 2 times x, or 2 times derivative of x, which is 1, times y dash, plus, and the derivative of 2y would be 2 derivative of y. Okay, now, can I replace y dash with something easier? So we're going to try to solve for y dash from here. So I'm going to take the pink terms here, and I'm going to subtract them to the right side. I'm going to have 2x y dash is equal to negative 3x squared minus 2y. Then I'm going to divide both sides by 2x. So I have y dash equals negative 3x squared minus 2y divided by 2x. And now I'm going to put that, I'm going to put this here and here. And so I'm going to have 6x plus 2xy double dash plus 4y dash, which is going to be 4 times negative 3x squared minus 2y divided by 2x. And so I can cancel out these, and I'll just leave it with 2, right? So now I'm going to have 6x plus 2x y double dash plus negative 6x minus 4y divided by x. And now what I'm going to do is I'm going to take some of these terms, the purple terms, and I'm going to move them to the other side so that I can solve for y double dash. So I would have 2xy double dash equals negative 6x. Oh, look at that. 6x and negative 6x cancel each other out. That's a happy coincidence. So I'm going to have 4y divided by x, and then I'm going to divide both sides by 2x, so it'll be 2y divided by x squared. Okay, now we're going to do 16a. Some weird variables here we may not be used to. It's not y and x, but same thing, right? So we're going to take the implicit derivative of 3v squared plus 2q equals 2vq, right? And then we're going to solve for dv dq. So we'll have 6v times the chain rule of v, so it'll be dv dq. And then that'll be the derivative of 2q with respect to q is just 2. And the derivative of 2vq, oh, that's a product, so we'll have 2 times v times the derivative of q, which is just 1. And then we'll have 2 times derivative of v, which is dv dq, times q. And then we are going to put these two terms on the left side because they have dv dq in them. So 6v dv dq minus 2q dv dq, and then we're going to put the other terms on the left, or on the right side. So we have minus 2 plus 2v on the right side. And then we're going to factor out v dash, or dv dq, and we'll have 6v minus 2q equals negative 2 plus 2v. And then we're going to divide both sides by 6v minus 2q, so we'll have dv dq equals 2v minus 2 divided by 6v minus 2q. And we can cancel out 2's from everything, right? So we'll have v minus 1 divided by 3v minus q. Okay, now they want us to take the second derivative of, but they want to take the second derivative of q with respect to v. So, one thing we could do is, if we know that dv dq is that, we know that dq dv is the inverse, or the reciprocal. Okay? And then, if we want to take the second derivative of that, then we could just use, let's see, that would be a quotient, right? So we're going to take the denominator, and we're going to square it and leave that in the bottom. So dq dv squared squared. The bottom is going to be v minus 1 squared. The top is going to be v minus 1 times the derivative of 3v minus q, which is going to be 3 minus dq dv. And then we're going to have minus derivative of v minus 1, which would be 1, times the derivative of the numerator, which would be 3 minus no, it would just be the numerator without taking the derivative, right? Okay. Let's see. So the first term, one thing we can do is we can replace this into here. Okay, so let's replace that. So then we'll have v minus 1 on the denominator, and then top we'll have 3 minus 3v minus q divided by v minus 1. And then on the right term we'll have negative plus q minus 3v divided by v minus 1 squared. We can simplify this first term a little bit. It's got a fraction inside of a fraction. So we could multiply the top and the bottom both by v minus 1. Let's try that. So then we'll end up with v minus 1 squared on the bottom. And on the top, we'll have 3 times v minus 1 minus 3v minus q. Okay, and so let's try to simplify that one more time. So 3v minus 3 minus 3v plus q divided by v minus 1 squared. And here we also have q minus 3v divided by v minus 1 squared. And so let's add those two together. The bottom is v minus 1 squared, and the top, let's see, we have 3v here, and we have minus 3v here. Those cancel. We have 2 q's, and we have negative 3v, so we'll put 2q minus 3v minus 3. This matches the back of the book, except for the back of the book has 1 minus v quantity squared for the denominator. Since it's squared, it doesn't matter if you do 1 minus v or v minus 1. It's the same, right? So that was a lot of algebra, but you can see like the derivative part of that is like pretty minor. There was this trick here where to save us work, instead of doing another derivative of the function, but with respect to v, we just took dv dq and we inverted it, and that became our dq dv. We can do that, okay? And then we substitute this into the first derivative, and then we just simplified with a lot of fraction algebra. And that's it.